Good morning, friends. My name is C.H. Srinath. My branch is Computer Science Engineering. My subject is Differential Equations and Vector Calculus. Today's topic about homogeneous linear differential equations. Homogeneous introduction of homogeneous linear differential equation is homogeneous linear differential equations are fundamental concept. This is a fundamental concept in mathematics, and they can be characterized by having all terms involving the dependent variable and its derivatives. This they can be characterized and having all terms involving the dependent variable and derivatives. Their solutions play a crucial role in various fields, including engineering and physics. In this homogeneous linear, their solutions play a crucial role in various fields, including the engineering and physics. And next is definition of homogeneous linear differential equation. What is definition of homogeneous means? A homogeneous linear differential equation can be expressed in the form of uh, by L into y is equals to 0. This is the expressed form uh, in homogeneous linear differential equation. Here, L represents a linear differential operator. The equation does not include any constant or independent terms. In homogeneous linear equation does not include any constant or independent terms. This is the definition of homogeneous linear differential equations. And see this picture, solve the non-homogeneous linear differential equations. To use this formula and solve the non-homogeneous also. And next topic, general form. Homogeneous general form is the general form of nth order homogeneous linear differential equation is this one. This is the general form of homogeneous linear differential equation. And next, the coefficients a in a naught I can be constant or functions of the independent variable if all are constant. The equation is called a constant coefficient homogeneous equation. This is the general form of homogeneous equation. And next one, the series pixel to solve the nth order homogeneous linear differential equation with constant. This is the formula to use and solve the problem. We need to find the roots of the nth degree auxiliary equation. Same an r power n plus an minus 1 x power n minus 1 plus a1 r plus a naught is equals to 0. This is the formula to find the roots of nth degree. Okay, this will include all the possibilities of distinct real roots, repeated real roots, complex roots, and repeated complex roots. Okay, to use these formulas and find the real roots, repeated real roots, complex roots, and repeated complex roots. Okay, and next one is characteristics of homogeneous equations. What is characteristics? Uh, Characteristics means the principle of the superposition applies to solutions of homogeneous linear differential equation like this. Uh, See this formula and uh, do that problem. It is a homogeneous equation. Dy by dx is equals to 0. This is the homogeneous uh, equation. And this is the problem to use this formula. The zero solution is always a solution of a homogeneous equation. Okay? Characteristics of homogeneous equations is the zero solution is always a solution of a homogeneous equation. Mm, Next, solutions of first order homogeneous equation. A first order homogeneous linear differential equation can be written as by track into by dx plus p of xy is equals to 0. This is the formula of first order. Okay. The solution can be found using separation of variables or integrating factors. Solutions, first order homogeneous equations is the solution can be found using separation of variables to in first order to separate the variables and integrating factors. Okay, to find the solution, the general solution takes the form by into yce into minus by int p of x dx. Okay, this is the formula of first order homogeneous equation. To use this formula and find the problem, to solve the problem. Next, solutions of higher order homogeneous equations. What is the higher order means? Higher order equations can be solved using characteristics equation. Uh, before and for an higher order means uh, higher order equations can be solved using characteristic equation. For an nth order equation, the characteristic polynomial is derived from the differential equation. The roots of this polynomial determine the form of the general solution. Higher order means um, to use the characteristic equation to find the solution. Okay, this is the higher order. And for an nth order equation, the characteristic polynomial is derived from the differential equation. The roots of this polynomial determine the form of the general solution. Okay, this is the solutions of higher order homogeneous equation. See this solution. Uh, okay, to uh, to find the how to find the solution. And next, characteristic equation example. What is characteristic? I will. What is characteristic? But characteristic equation example is the consider the second order equation y double dash plus py dash plus qy is equals to 0. This is the second order equation. Okay, and the characteristic equation is given by this formula. Um, the solutions depend on the nature of the roots, real and distinct, real and repeated or complex. This is the solutions. Solutions depend on the nature. Okay, and read these formulas and to use these formulas and do problems. Okay, consider the differential equations. And next is real and distinct roots. What is real and distinct roots? If the characteristic equation has two distinct real roots, what are they means? R dash 1 and R dash 2. The general solution is y is equals to c underscore 1 e into r underscore 1 into plus c underscore 2 e into r underscore 2 x. This is the characteristic equation has two distinct real roots. Okay, this solution represents two linearly independent solutions. It shows how the behavior of the solution changes based on the roots. Okay, real and distinct roots is shows the behavior of the solution changes based on the roots. Okay, see this picture. And next one, repeated roots. What is repeated roots means? If the characteristic equation has the repeated root, the general solution is, this is the formula solution of the um, t- to use this formula and do problem. Okay, this is the general solution in repeated roots. This indicates that we have one solution derived from the repeated root and a second solution involving x. Repeated roots, repeated roots reflect a unique behavior in the solutions, growth or decay. Okay, next one is complex roots. What is complex roots means if the characteristic equation has complex roots, R is equals to of alpha of Pm of beta I. The general solution is this is this is the general solution. This form of demonstrates oscillatory behavior modulated by an exponential factor. Complex roots often arise in physical system with oscillations. This is the picture. This is the figure. And the complex roots of the characteristic equations 2. Khan Academy in Khan Academy. Okay. Second one. Next one is applications in engineering. Homogeneous linear differential equations model many physical phenomena such as vibrations and electrical circuits. They help in analyzing stability and response of systems. Solutions can predict behavior over time, essential for design and control in the engineering. This is the applications in engineering. Next one, numerical methods for solutions. In some cases, analytical solutions may be difficult to obtain. Numerical methods such as Ringkutta and finite difference methods can approximate solutions. These methods are particularly useful for initial value problems. And next one, summary of key points. Homogeneous linear differential equations are essential in understanding dynamic systems. The form of roots of the characteristic equation guide the solution process. The process of superposition allows for the construction of general solutions from basic ones. Next one. Challenges in solving. Identifying the correct method for solving can be challenging due to the varying coefficients or orders. Special cases may require unique approaches or transformations. Understanding the underlying theory is crucial for effectively applying this equation in practice. Next one, conclusion. Totally homogeneous equation conclusion is homogeneous linear differential equations are cornerstone of mathematical modeling. Mastery of their solution equips one with tools to take complex real-world problems. Continued study and practice are essential for proficiency in this area. References of the homogeneous equation. Codington, an introduction to ordinary differential equation. This is the references. Thank you.